Thanks so much, Allison. There's nothing more than that I like to talk about than photonics. I've been coordinator of this program for over 15 years and a part of the program since its start over 20 years ago now. And we have seen amazing success from our graduates going through this program. And we're going to talk about a lot of those different career paths from the program as we go through this talk. There are two programs available in photonics. We have a photonics engineering technician and a photonics engineering technologist program. Allison, would you mind just flipping the, and a lot of people ask me, Alex, which of these two programs should I register in? And the good news is it doesn't really matter. In most cases, I really encourage students to enroll into the 3-year program because the first year is completely and totally common between the two programs. And if you decide after 2 years that, hey, I've got a job lined up, or you want to make a slide over into another engineering technology program, it's really easy to do if you've taken the technology program. The only difference between the technician program and the technology program in year 2 is the addition of 2 math courses. So the technology program gets calculus in year 2, the technician program does not. Other than that, the two programs are entirely identical for the first 2 years. So you can flip-flop between the two programs right up to and including second year based on whether or not you take those 2 math courses. So I really encourage people to enroll into the technology program, and it's very easy to transition out after 2 years if you want to do so. The advantage of taking the 3-year program is that it provides an extra level of theoretical knowledge of the photonics industry, but as well, we do a lot of project-based work that we're going to talk about a little bit later. And you also get involved in a capstone project, which occasionally we try to link to private industry as well. So you can almost think of it as a bit of a co-op opportunity that we often offer our students in that 3rd year. So the question that is always on everyone's mind is, photonics sounds cool, but what is it? What is it really? People say, something about light, something about lasers, fiber optics maybe. And a lot of people think of it as this really niche program. It sounds like it's cool, but there must only be a few jobs somewhere, tucked away that you can get from this program. And nothing could be further from the truth. Although, oftentimes people talk about photonics as niche, the reality is the program is a foundational technology program that's utilized across all the traditional disciplines. So if you come into the photonics program, you get exposure to mechanical technology, you get exposure to electronics, electrical technology, those fundamental engineering technologies that everyone knows about. But on top of that, you also get exposure to what you might consider to be emerging technologies like fiber optics, laser technologies, precision optics. Although the reality is Ontario has been doing precision optics for 70 plus years. Ontario has been a leader in precision optical technology. So really what photonics is an integrated manufacturing technology program, one that gives you exposure to all the traditional programs as well as a leg up in optical and laser-based technologies. This is a few images of our main, what we call our Flex Lab. So the Flex Lab space, which is located in the Voyager wing of the Welland campus, allows us to do a lot of fundamental optical alignment stuff. So if you think about traditional telescopes, for example, we actually build small versions of those on these optical breadboards that you see in that image. We also, right from the very beginning, we expose you to lasers. We don't literally expose you to the lasers, but you get to use the lasers almost from day one. So we have some low power lasers that are relatively safe. And these are a little bit more advanced than the ones that you use to tease your cat. But you're aligning optics, you're handling optics right from day one. And those skills will carry you through the entire program. And interestingly enough, although you might look at it as very fundamental, learning how to clean a lens or learning how to handle a lens, those skills that you get, like I said, almost from day one, are the very same skills that are going to get you hired versus someone from one of the traditional engineering technology disciplines, because those are skills that you just can't get anywhere else. We also have what we do photometric testing in this lab. So where we'll take light sources and we'll measure their optical power and measure the color of the light sources. This is something that's become really important in recent years as we've transitioned from the old traditional incandescent light bulbs to modern LED light bulbs, which have different properties in terms of their color and their powers. So we're one of two institutions that I'm aware of in Canada that actually provides training in optical testing of that form. We also get into things like machine vision, which of course is used in all kinds of things for manufacturing. But of course, if you think about autonomous cars either use LiDAR, which is a laser-based navigation system, or they use vision-based technologies for navigation. So we give you exposure to that kind of technologies. We also get into fiber optics. For fiber optics, telecommunications, fiber optics are used for sensors, all kinds of interesting things. Fiber optics are now commonly used as the main form of communications in aircraft and even in automotive applications, because fiber, which is just literally little strands of glass, is so much lighter than the traditional cables that we would use, which are made out of copper. So we also get into that in this main lab. And we also give you some exposure to some fundamental programming skills as well, such as Python and digital programming and things of that nature as well. One of the crown jewels of our lab facility is our teaching clean room. Now, you might not really know what a teaching clean room is. You presumably know what a clean room is, but this is a different kind of clean room. I don't know if you've seen the old Intel commercials where you see guys and they're almost like dressed up in spacesuits for Intel, and they're dancing around in these labs making computer chips. Well, this is that kind of environment. We don't dance quite as much, but we do have the capability of creating optical devices. And so that technology is called vacuum technology, and we have a wide range of systems. You can see some examples here. We have glove boxes. We wear clean room garb. And the idea there is to keep the environment clean from you. So you may have seen these great big rooms at NASA where they'll have the satellites in there, and you'll see guys wandering around in these clean room suits. It's very much that kind of environment where we're teaching people how to properly how to properly dress and how to properly act in that environment to keep everything extremely clean. A lot of our graduates end up working in industries where they're making lenses and putting optical coatings on those lenses that will eventually end up in outer space. And if you know anything about the Hubble Space Telescope, one of the major issues with that particular space telescope was due to contamination from someone wearing cologne in the clean room. And so we're talking about, when we're talking clean, we're talking about, really the ultimate level of clean. And so we can get into all kinds of interesting optical coating technologies using that facility. Again, when we talk about what is photonics from our perspective, yes, it has a lot to do with light-based technologies, but we're manufacturing those technologies. So our graduates are going to go on to making mirrors, and you say, well, what's the big deal about making a mirror? Well, these are mirrors that, again, that are going into outer space, or they're lenses that are being used for Steven Spielberg, for example. And I know for a fact that our graduates make the lenses that he uses in his cinematic cameras. We're manufacturing devices that are going into cars, that are going into aerospace applications, that are being used for camera systems, for military applications, for entertainment applications. We're building devices that are being used for biomedical devices. So for biomedical imaging, laser scanning, ultrasound machines, laser scalpels, things of that nature. So we do a lot in the optical manufacturing side of it, optical coating, but we also, of course, get into the traditional technology manufacturing sides, such as through-hole soldering, surface mount soldering. So the population and the manufacturing of circuit boards, that's part of our curriculum as well. So we also have something that's very, very special, which is what's called a class 4 laser lab. So as I mentioned, in our flexible lab space, we have lasers, and those are what we call class 1, class 2, class 3 lasers. Those tend to be relatively eye safe. The class 4 laser lab is a lab that's reserved for second year and third year students, because those are the lasers that, you know, could theoretically maim you, cut off your arm, you know, they're the really dangerous lasers. So we want to make sure that we provide an adequate level of laser safety. And so we provide laser safety training in year 1 for 2 semesters, where you're getting exposure to those low power lasers. And then in year 2 and year 3, you get access to the high powered lasers. And of course, in industry, those lasers are used for a wide variety of things. It can be for laser cutting, laser welding, the automotive industry, and the, again, the aerospace industry make use of laser-based cutting and welding technologies quite widely in their fundamental manufacturing technologies. We also have some really high-end lasers that would be used for research and biomedical applications. So again, like that green laser that you see there, a variation on that laser is what's used for laser scalpels, for example, or is something, it might sound silly, but for laser hair removal or laser tattoo removal. It's all the same basic technology, just used in a slightly different way. You'll notice that those tables look incredibly thick. And the reason for that is because we can also do things, I'm sure you've heard of holograms, for example. And we do optical testing, and some of those lasers were used to produce holograms in their previous life. And that's they're really sensitive to vibration. So that particular table that you're looking at there actually weighs very close to a metric ton. And that's to minimize the amount of vibration felt by the laser. So we teach you all about that, teach you about isolation of the technology of the lasers as well, and how those vibrations can affect your output for your laser. So you want to talk about sensitivity, and going back to talking about making mirrors. People are like, making mirrors, that sounds like nothing. Well, one of my graduates works for a company in California that made the mirrors that were used in LIGO. And if you're not familiar with LIGO, LIGO is the system that was used to detect gravitational waves. Now, if you have any sense of how weak a gravitational wave is, it's, you can't feel it, right? It can physically pass through the entire planet without anybody noticing it. So we're talking about a level of precision that is almost unfathomable. And those were created at a company that one of my graduates works at. And again, the whole system is based on laser technology. So there's a little laser that's bouncing kilometers long, and then that subtle vibration as it flicks off that mirror is what we're actually detecting. So again, you can look at those high-powered lasers from a kind of a laser modeling standpoint. We can look at, what goes into the lasers themselves. How do you repair those lasers? How do you fix those lasers? What can you do to change that laser to make it function better? Some of our graduates have worked at companies that have actually designed the laser system that they use for cutting and welding. Other grads work for companies that's all they do is sell lasers for laser cutting and welding. But then you have the whole other side of it, which is once you've got your laser cutter or your laser welder, what are the appropriate power levels? How are you going to actually physically use that laser to cut that material? Because every single material reflects light differently. And of course, all a laser is just a giant source of light. And so you need to figure out how that particular laser is going to affect that particular material that you want to cut or weld. And that's not a simple process. And so what we do as part of the program is teach you to actually look at how can you modify laser properties? How can you modify that light in such a way that it can cut through a material without setting it on fire? So good example of that is I worked on a project many years ago where we were doing laser cutting of plants. And it was really, really tricky because you had to modify the beam shape of the laser in such a way that it would cleanly cut through the plant. Because if you didn't, it would superheat the sides of it. And either you would blow the plants up, you'd take the water and vaporize and blow it up, or you would physically set the plants on fire. So it was a very, very special property right in there. You had to get it just right in order to cut the plant and cauterize the plant, rather than, of course, if you think about a traditional approach, which is cutting with scissors or something like that, that's actually a highly destructive process. But if you can get your laser just right, you can get a nice, perfect, clean cut. If you get it wrong, you set the place on fire. But that's why you come take the program, right? So those things don't happen. So again, and you may see this recurring theme about manufacturing. People talk a lot about advanced manufacturing. If you're talking about any of the other engineering technologies, they're going to talk about robotics and how they use robotics to do advanced manufacturing. And it's really, really cool. But here's the thing. Without a program like Photonics, without graduates like my graduates, you can't have advanced manufacturing, because we manufacture the advanced things that makes advanced manufacturing work. And so that's really what, you want to talk about niche, that's our niche, but it's so critical and so important that you can end up working in almost any industry because they require that level of support. So we do a lot of interesting design work as well. We do a lot of additive manufacturing. So if you're familiar with 3D printing, we do 2D modeling, we do 3D modeling, and then we do a lot of 3D printing of components, especially when we talk about optomechanical hardware. We'll 3D print it first and try it out and make sure that that will work with whatever particular lens. I can see Christina's on our call now. She teaches our optical course. So she'll teach the students how to develop the optical system itself. So you have to figure out, I need this lens and this lens and this lens to get my telescope to work. And then once you've got that, you gotta mount your lens somehow, right? So we'll go into another type of CAD program and we'll model the mechanical side of it. We model it, design it, still works great, and then we'll physically build it. We'll print it and see that it works. Again, we do soldering, because we have to, again, you've got these lenses, well, you're gonna stick a camera on there probably, right? And that camera is going to be an electronic circuit board. So we're taking light and we're converting it into electrons. And then we're gonna take that and we're going to dump it into a computer, right? So we're gonna look at the machine vision and the programming associated with that. And then we're going to laser weld and cut the whole thing, right? Why not? So here's some examples of some of the student work that was done last year. So it was a little tough last year because although we were running a lot of our labs on campus, we were trying to keep as much of it as remote as possible for safety's sake. And I was really impressed with what the students were able to do. So some of these are from the capstone project. You can see the telescopes were actually, again, they were designed with the help of Christina and myself, the optical side of it. And then they designed the mechanical aspect of it. And then they 3D printed it. In some cases, my students actually went out and they bought their own 3D printers because they were so excited about this work that they went out and just bought their own printers so that they could start manufacturing their own their own stuff. It was really, really great. We have 3D printers on campus, so you don't have to do that. But it's when you realize what you can do once you have that capability of being able to model something on a computer and then realize that you can make it manifest within a few hours with a printer is just, it's incredible. You can also see in one of the other projects, there was a spectrometer. A spectrometer is a device that takes light and then basically kind of blows it up and splits it up into all its component parts, all its component colors. Oftentimes you'll hear about astronomers saying, oh, that star has, so much hydrogen and it's got some helium and it's got a little of this and a little of that, and this galaxy has this element and the moon has this. Well, how the heck do you know what a star is made up of or what a planet is made up of? And it turns out, based on the color of light being either reflected or being emitted by those objects, you can determine what that object is made out of. And that's the art of spectroscopy. And spectroscopy is used everywhere. It's used in mining, it's used in the food industry, it's used in the medical industry, it's used, agriculture. Name something, and there is an application for spectroscopy in it as an analytical tool. And so our students made their own spectrometers from scratch. So we took CCD sensors out of like $3 web cameras, took the web cameras apart, and then they designed their own spectrometer, and they used their own lenses. And designed and built this device that could take light in and then analyze it. And then they built their own software or designed their own software that would analyze the light output and tell you, what it contained. The bottom, and I'm sure some people are like looking at the bottom right there and saying, they built tanks. Is that a tank? Well, yes, it is a tank. And no, they didn't build the tank. I'm sure you could 3D print a tank. I don't know how effective it would be. But what that actually represents is some of the students built laser scanners. So again, you recall at the beginning, I said in a lot of autonomous cars, they use what's called LiDAR. So it's a laser-based scanning technology that allows you to map out your surroundings. And that was actually a toy tank that one of the students had, and he built his own laser scanning system. And that's actually a point cloud of the tank that he laser scanned himself using basically parts from around the house. And I think he 3D printed a few things as well. But that's one lab from one course of our imaging courses, just building your own laser scanner. And it sounds really difficult. It's not, I wouldn't say it's easy, but using the skills and the knowledge that you get from the program, you can do it. So let's talk about the career opportunities. And let me tell you, there are a lot of opportunities out there. Again, we're a foundational program. Everybody needs optical technology in some way, shape, or form. You're looking at me right now on a computer screen of some sort that's either powered with LEDs or laser diodes, or God bless you, maybe it's even a CRT. Probably not anymore, but it's a light emitting device. That's photonics, right? If you're looking at me through the internet, that's light-based technology too, because the internet is the backbone of it is all fiber optics based technologies. Even if you're communicating over Wi-Fi, you're connecting over Wi-Fi, your router at some point is connected to a fiber optic cable, and it's going back to the main switch, right? Some of our grads, it's really, really neat. The ones that are working in the biomedical and the life sciences sector. This is one of my favorite sectors because, a lot of my grads say, well, there's tons and tons of jobs in defense and a lot of military applications and things of that nature. But what can I do that's not that? And this is the career path. And a lot of our international students actually go down this particular career path. So what does life sciences have to do with photonics? Well, virtually any kind of diagnostic imaging technology is light-based. So if it's think about an ultrasound machine. That will be like, well, okay, yeah, the display, that's photonics, but I don't see any, it's not, there's no lasers shooting out of that thing or not. No, but the antennas that actually generate the ultrasonic signal are actually cut using what's called an excimer laser. And excimer lasers are incredibly they're temperamental is a polite way of putting it. They're a very difficult laser to maintain and get to work properly. But the reason why we have to use them is because they generate ultraviolet light, and the ultraviolet light is really, really short. And that allows us to manufacture machine incredibly small features, which allows you then to generate these teeny tiny antennas that can generate the ultrasonic signals used for ultrasound machines. The kind of the newer technology that's come out recently is called a laser-based, it's kind of a laser-based ultrasound machine. And whereas with an ultrasound machine, it only detects changes in density. So, for example, if you've got something in you that's really, really dense, like your bones, of course, you can detect that. If you've got some like a cancerous tissue or something, a tumor that's really, really dense, you can detect that. But what if it's precancerous, or it's very early in its development? Can't really see that with an ultrasound machine. But with a laser-based system, it's all dependent on absorption. So what happens is, based on the color of the light that you're shining on the body, the light will either transmit throughout the entire body, or it will be absorbed. And you can actually change the color and actually detect the difference between things like oxygenated blood versus non-oxygenated blood. So you can look at a particular point in the body and say, wow, that point in the body is being starved for oxygen for some reason. I wonder why. And you can go in and dive in and say, oh, there's a cancerous tumor there, for example, or something that's early in its development. So you can see features in the human body using this technology that you can't with traditional diagnostics technologies. What if you want to actually see what's going on inside a vein, for example? How the heck are you going to do that? Well, you take a fiber optic cable and you just put it in the vein, because the fiber optic cable is so small that you can actually take and make a tiny incision in your leg and actually feed that fiber optic cable all the way up that vein, through your leg, up your chest, and actually into your heart, and take images inside of your heart or inside of particular veins in your body, inside your head, in your brain. Because what we're doing is we're transmitting light up the fiber optic cable and then looking at the reflected light down that cable back at a camera that's located on a bench somewhere. And it's you kind of think about it. Oh my God, like you're sticking cables up you. Again, this is a cable that's thinner than a human hair. So it's very, very small and not invasive, compared to a traditional way of, checking your heart health would be, like cutting your chest open and let's see how that heart's doing. We can actually take images inside the heart. One of the folks there, the one that's, you're not looking at his muscle tone there, but the fellow that's got the laser safety glasses on there, he works for a company. He's a former graduate of our program. He works for a company in Kitchener-Waterloo area. And his job is actually to monitor the lasers that are used for surgery, but he's not a doctor. So he's actually the technologist that's in charge of looking after the diagnostic and the laser equipment during the surgery. And it was a funny thing with his case is he was actually hired as an electronics technician, even though he's a photonics fellow, but he had an electronics background as well from the program. And he saw some engineers trying to fix a laser one day, and they were having a heck of a time trying to do it. They couldn't line it up. They couldn't get it to working. And he asked them, hey, could I try this? Could I see if I could get it to work for you? And they laughed at him. because they're a bunch of engineers. How is this technician that just started going to fix this incredibly sophisticated laser? He said, go ahead, give it a shot. He walked up to it. 15 minutes later, it's all running, and they gave him a very large, healthy raise after that, and he moved up very, very quickly in the company. I understand that he gets free massages on Thursdays and stuff like that too. It's just an unbelievable thing. But yeah, there's some really great careers either in the application of the laser technology, so again, as a technician on that side of it, or in the manufacturing side of it. So again, as I mentioned earlier, there are massive, massive, massive jobs available in the defense sector, defense and aerospace. A lot of the companies that we work with specifically are in this sector. And of course, they have other fields as well. So, for example, here we have Raytheon and Westcam, which is L3 Harris now represented. They're both companies that produce a lot of materials for the defense sector. So Raytheon, for example, in Midland, just north of Barrie, produces the best rifle scopes in the world. And I'm not just saying that to brag, it is a known fact that their rifle scopes are the absolute best in the world. Their optics are the best. But that company also, in that exact same facility, they also produce lenses, as I said, for cinematic use. So they produce lenses that are used for cameras in Hollywood. Very, very high-end, high-level lenses that are used for those applications. They also have another line, unfortunately I can't talk about, but it's used in a lot of single-use products as well. Can't talk about those, but you can probably figure it out. L3 Harris, on the other hand, they have some really interesting products that are used in aircraft. So, for example, I don't know if I've got a picture there, but you can see there's a drone that has a turret under it. And so that turret was actually produced and manufactured at the Burlington division. Actually, it's Hamilton now, the Hamilton division of L3 Westcam. And they're probably the company that hires the most grads from us. And they're again, starting salary there is somewhere in the neighborhood of in the mid 40,000s of dollars, which, 2-year, 3-year diploma coming out of college with zero experience other than what you've received from the program, and you're stepping into a job making somewhere in the mid 40s is pretty amazing. They have a division in Don Mills as well that's hired a lot of our graduates. And that division actually produces the lenses that are then used in those turrets and camera systems being produced in Hamilton. And I think the last time I talked to the HR person there, they said they had, I think, 5 or 6 open positions. And they told me, even if every single position was full for that particular job making these lenses, we would still hire more of your graduates because we want to have them on standby for that particular position because it's so hard to get people. They also hire people in the, again, they have a clean room very similar to ours where they're doing optical coating. So they're putting coatings on those lenses. It's what we call an anti-reflective coating to maximize the amount of light that the lens can collect and then transmit eventually into a camera system. As well, they produce high-end mirrors as well, some of which are actually coated in gold that are used for infrared and night vision, far infrared applications. And of course, even in outer space applications, which is kind of interesting. I think if you flip to the next slide, oh no, that's telecommunications, but maybe it's the next one in the entertainment industry. Some of our, actually you can see DALSA there. Teledyne DALSA is an interesting company because they produce a lot of stuff for the entertainment sector, which is represented here, but they also produce camera systems that have gone to Mars, for example. So we've had grads that have actually worked on equipment that's gone to Mars. Even talking along those lines, we have folks that work for Blue Origin which probably the most the thing that's been the news most recently is the fact that William Shatner went up into outer space on a Blue Origin rocket. But we have folks working there. Getting into the entertainment sector, again, as I said, Raytheon produces cinematic cameras, so does DALSA. Chrissy Digital is based in Kitchener-Waterloo area. They produce cinematic projectors. So if you go to the movies, chances are it's one of their projectors that you're actually watching the movie. I had one of my graduates reach out to me recently, and he was actually at the red carpet premiere for a movie, and he was setting up the projectors for it. It was Chrissy Digital at the time had a new product out there. It was a 6 laser 3D laser projection system, really cool, very high end system. And yeah, he's like, oh yeah, I'm at the red carpet, I'm setting up the lasers, and that was really cool. And he actually works now for a biomedical company. He switched to, I think it's called a company called NDI that does biomedical imaging. But yeah, it's really fascinating. And again, it's not just movies. You can see they've done projections onto buildings. They actually have some really cool display technology that's stacks up like tiles. So they can create a screen anywhere using these small, I think they're 1 foot by 1 foot tiles, and they can create any size display you want from that. So you can create something 3 stories high or as small as that 12 by 12 foot display. It's really quite neat. If you're watching the news and you see those big command centers, chances are Chrissy Digital actually did the command center in the background as well. Can we just flip back to the last one, Allison? So yeah, the telecommunications sector is also, again, massive for us. And a lot of our international students work in the telecommunications side as well. We've got a company called Optics in Ottawa that's hired a lot of our international students. They also have a division in China that they run as well. And that particular company produces a lot of the devices that go into fiber optics based telecommunications equipment. So again, without companies like Optics, you wouldn't have the internet. You don't think of these companies as they're just like this little tiny company off in Ottawa, but they're foundation to modern society. And they need people because no one else is giving graduates this kind of training. No one else is teaching people how to manipulate fiber and fuse fiber for a manufacturing application like this. Oh, and that's photonics in a nutshell. But there's so much more. There are any industry that you can possibly think about. There are career paths for a photonics graduate, and some of our graduates have gone on to onto university. Interestingly enough, some of you may be aware that Donna Strickland won the Nobel Prize for physics, I think, 2-3 years ago now. And one of my graduates from the program happened to be working in her laser lab at that time, which was really exciting. He had gone to University of Waterloo and was working in her lab. So it's really a fascinating thing. You can take this career anywhere in the world. Of course, there's jobs in Germany, Korea. A lot of our grads end up doing actually a lot of globe trotting. If you're interested in doing field work and you're willing to, be in Germany one day and, in the States the next day and Korea the day after that. I guess it doesn't really work in terms of the how long you're gonna be on the airplane, but you get the idea. There's if you're kind of interested in those kinds of jobs, there's some really neat ones there. I know I actually had one fellow, he didn't, and this isn't the best example because he didn't even actually technically graduate, but he had his US citizenship, dual citizenship, Canada and American, and a company down in the States. As soon as he saw that he had the education that he did and he had American citizenship, they gave him a signing bonus immediately. He moved down to New Mexico.
I think it was New Mexico. Was it New Mexico?
It was
okay, what happened? Where is he?
Now, well, he's actually on the West Coast now. He's in San Francisco. I was there a couple of years ago, and I met up with him, and he took me for a tour of the facility. He's working for a company called Zygo Precision Optics, which makes some of the most precise optics in the world. And yeah, just amazing.
Alex, it happened. The one-time use thing that you couldn't talk about, that's me right now. Thank you. Okay, not that I have any prerequisite knowledge whatsoever, but I am fascinated by this. If I wanted to just absorb you every day, what would I need to get into this program?
Well, the requirements are your grade 12 math and English. That's all we need. We used to have a physics requirement, but we realize how difficult it is to get physics at some of the high schools, and we want to make it as easy for people to transition into this program as possible. So although you don't have to have physics to take the program, if you have the opportunity at your high school, we recommend it because it's going to make your life just that much easier. But you don't need it. And Christine is actually teaching our introductory physics, and she knows that. And so she's going to make it as easy as possible to transition people into the program. And the thing is, a lot of people look at it and say, oh my goodness, this is so cool. But like, this has got to be like the hardest program in the universe. There's no way I could do this. And okay, is it easy? No. But we're here because we want every single person coming into this program to be successful. And the reality is some of these companies, they want people that know how to clean lenses, which doesn't sound very complicated, and it's not. But the reality is people aren't trained to do it. People don't know how to handle a lens. And you're like, well, so what? It's a lens. Like, I handle my glasses all the time. Well, the lenses that we're talking about, I remember I walked into a fab one time, and he handed me an unfinished lens, and he said, yeah, that material you're holding right now, that's worth about $10,000, and we haven't finished it yet. So it is really important that you know how to handle this stuff properly. And so if you take this program, even the 2-year program, you don't have, we want to keep you for 3 years, but even after taking this program after 2 years, you can get a really good job just because you took this program, because you know how to handle optics, how to treat them. And it's interesting because our graduates are getting jobs that in some cases that we have a fantastic mechanical program at college too, but for these particular companies, they prefer our graduates because a mechanical student is not used to dealing with something like a lens. They're used to machining aluminum or steel, not glass. And glass behaves in a different way, and handling glass is different. And so it's just the skills are something you can't get anywhere else. And so if you take the program, we're going to take you by the hand and try to give you as much practical experience as we possibly can, as well as some theoretical that might hurt a little bit. But it's the hands-on skills that you're going to develop that are going to get you the jobs. It's not the theory.
If I may, it came to mind, I thought when you were speaking of that graduate that got hired for one job in the hospital and healthcare system, and they realized what he could do when he fixed that laser within 15 minutes. Now, you said he works alongside the surgeons to take care of the equipment. So
right.
What's thinking in my head is there's the important surgeon who's making big money, but his tools, I never even thought that you would have to have somebody on standby, because if something goes wrong,
well,
you
can imagine if you're doing open heart surgery and that laser scalpel goes down, what do you do? Right? It's scary. Like I had to have some x-rays done earlier this week, and and the x-ray machine wasn't working quite properly. And it's like, don't worry, like this is what my grads work on. Not that I'm going to mess with the x-ray machine, but it's this equipment is incredibly sensitive, precise equipment, and not just anybody can work on it and repair it. You need somebody that's properly trained for it. The doctor can't walk over and kick the machine until the laser kicks in. Absolutely,
but they're just as vital as the doctor. That's to add to your point. And it you don't think of these things from somebody from my perspective, it just doesn't.
It was funny, that particular graduate, because they used to, the way the system, the laser scalpels used to work is they would use a red laser as the spotter, because the laser that actually does the burning, obviously you don't want all the time, right? So there's a sight laser. The sight laser comes on and it's red and it shows you where it's targeted, and then you fire the laser. But the problem is, you can imagine you're a doctor, doing surgery on someone, well, there's blood and whatever, you can't see a red laser, right? So what they used to do is they would go over somewhere clean and go zap and say, oh, okay, there's where my laser's pointed, and then go back to doing the surgery. And then my grad says, like, why aren't we just putting in green lasers for the pointers? And everybody's like, yeah, why aren't we doing that? And it's funny, and it's, and again, in some of these companies, our students are the first students that have experience in laser health and safety training. So they're going in and they're making changes to protocols as far as laser health and safety is training. I remember another one went for a job interview at a company it's a subcontractor for NASA, of all places. She went on the interview and she went for a tour of the facilities, and she's like, you're doing that wrong. You're doing that wrong. You're doing that wrong. And I'm like, oh my God, like, I hope, I hope you didn't burn some bridges there for us. And I got a phone call from that company, and they said, how much should we pay this person? We have never seen anybody with this level of knowledge and understanding of what we do, because we don't even really understand. We know if we do something a particular way, it works, and we don't change the process. She actually understands why the process works and how to improve it. And so, yeah, and she ended up working with Burt Rutan, who's one of the preeminent aerospace engineers of our time. He actually was the designer for Proteus, which was the first commercial space plane. So yeah, like these people are doing amazing things.
That's awesome. And it obviously comes from amazing people, because like I said, Alex, this has just been fascinating. I don't know if you noticed, but a bunch of my colleagues jumped in as well too, because I received messages just about how lucky I am to have been able to moderate this session, because they said he's just so passionate. One young lady wrote, he's so passionate. And absolutely, I have been so naive in my life, and you have profoundly changed me for a few reasons. Most of all, I want to say, I thought there were two kind of people in this world. You were smart or you were funny. How wrong was I? Alex, you are just the most amazing orator. Thank you so much for
that's the only reason why John actually keeps me around. It's not for my smarts.
Listen, this was fascinating. I think we have a couple of, we're just saying hi to some folks. That's great. We have recorded this and we're going to include that on there. But what I'd like to point out is that your contact information is right there. If anybody has questions, I know
please,
you would
share. Please email me. Traditionally I used to give one-on-one tours of lab all the time. Hopefully we can get back into doing that. Don't call me right now, because I'm not on campus as much, but please send me an email and I'll talk your ear off.